All right, so we are now on night 3 of Authentication Week. So on night 1, I introduced you guys to the concept of auth. We started thinking about hashing and good practices for passwords and got a little bit of a lay of the lands. And then on Thursday of last week, you had Dan for sessions and cookies and explored the first technique that we're going to see of how does it know we're still logged in? So this technique for making sure that once we log in or register that we stay logged in until either we log out intentionally or a certain amount of time goes by or we switch devices. So you guys saw one way of doing that, which is sessions and cookies. And tonight we're going to explore another way, which is web tokens, a little bit more of a common way, though both techniques totally work. So before we get into web tokens, I want to do a little bit of a recap of sessions and cookies. So go ahead and share in Slack. What did you guys learn last week about sessions and cookies? Who can sum up what those are, how they work, or just give me a little slice of the cookie, let's say. So go ahead and share in Slack some interesting tidbits you learned last week about what sessions are, what cookies are, and how they work to allow you to stay logged in on an app or on a website. A session follows a user around every request. So I think you've tapped into something that's actually really important, both for sessions and for what we'll see tonight with web tokens, which is this idea that if you're logged in, every single time you make a new request to the server, we need to make sure that you are logged in. Because if actually me makes a request I log into my bank account page and then make a request for something, and then immediately afterwards someone else makes another request to my page, I don't want my credentials to give them free access. So every single request needs to be verified. And in the case of sessions and cookies, the way that we do that is the user will have a cookie and we'll make sure that that matches to a session ID inside of our data store or database so that we know they are who they say they are and they have a valid session. And on that note, I see another great response, which is that sessions keep track of a record of who is logged in and cookies are how you keep track of each logged in user. Exactly. So you can think of cookies as the things that travel back and forth on the requests. The cookie will first be generated when the user is verified, either on a register or login, and then it will continue to travel on every single request. The backend doesn't need to keep sending it, but the front end needs to send it every single time. And then what we can do is check. So then what we can do is on the back end, check that against our ledger. Essentially, the sessions are, we keep a list of every user who's logged in and information about how long they should be logged in for. You know, if there's an expiration of, say with a bank account, you would hope it's something like 10 to 20 minutes. With social media, it's usually almost indefinitely. So together, they become this technique for keeping track of who's authorized to see what. So we'll see tonight web tokens, which are a very similar technique that end up accomplishing pretty much the same thing. But let's start by talking about one of the issues with sessions. So sessions can have a little bit of a scalability issue. Does anyone either know or can you guess based on what you know about sessions why the session approach might start to have an issue when you're talking about hundreds of thousands of users, for example? Why might sessions be a little bit less scalable than what we would like? I see a couple people typing, so I'm gonna wait to see. Okay, we store the session on the server, and if too many users are added, it might require a dedicated database. Absolutely. So you guys probably talked about different places to store sessions. Generally, you do want somewhere dedicated to store them, whether it's a data store, something like Redis, or a full-on database. But either way, you end up with something like Redis. It's a little more optimized to be accessed that frequently, but you're still going to end up with a bunch of these sessions piling up and this need to access them elsewhere very quickly. So yeah, they're going to end up taking up a lot of space and slowing down your app as you're constantly trying to verify your users. So what's awesome about what's awesome about web tokens is they're very cleverly designed to kind of get around this problem. So at first it may be a little difficult to see how they work and how they differ from the session and cookie approach. So before I even share my screen, we're going to start by kind of exploring the theory behind how web tokens work so we can get a sense for them. And then we'll dive in and actually look at implementing them using a library, which, quite like we saw with the sessions, we're going to use a library that's going to make our life extremely easy. So let's talk about the theory behind web tokens. So think of it this way. I, the client, will start off with a basic login. We already know someone's registered, their password's stored as a hash. We know how that works already. So let's just say that I have my credentials and I go ahead and I log in. So what's going to happen is I, of course, send my credentials and we'll assume that they're correct. And then what's generated is a web token. And a web token is like an access pass that says, similar to a session, it says that says who I am and how long it's valid for, and if there's any other information like a role or privileges, it's going to contain that. So it's like this access pass, very similar to a session. Now here is the big difference. The difference is that this is not going to go on, it's not going to be stored on the back end. Instead of being stored on the back end, it's actually going to be, the whole thing is sent back to the client. So the whole thing is going to be sent back to the client. So now instead of being stored on the back end, my whole access pass is being sent to the client, and it's the client's job to keep track of that. Sometimes they're even wrapped in cookies, but let's say we're storing them in local storage or something like that. And this thing is encrypted, of course, but it's now the client's job to store it. So instead of one server having to store tens of thousands of session information, every single, my computer is, say, responsible for storing, 10 tokens, because let's say I'm logged into 10 different sites. So here's the really awesome thing, which is this is what happens when I send this encrypted thing back. So I have this token, I'm sending it back to the client, back to the server to say, okay, I want to access a new page. So I send back my little access pass. And they're going to use, so they only have to keep track of one thing, which is one super secret password that unlocks this. But the way that it's designed, and this is where it gets really subtle, the way that this token is designed, if anyone has tampered with it, the server will know. So this is the really subtle, critical point of sessions. And I want to keep saying sessions, of web tokens. This is the subtle point of web tokens. And I'm going to say this a bunch throughout the night, but I want to introduce this idea before we even see any code, which is that instead of storing all the information on the server side, the server's main job is to make sure that no one has tampered with this thing. And we'll kind of see how that works once we dive in. So, but for now, take a leap of faith and say that this thing is designed in a way that the server will know if it's been tampered with. So now if I try to take my web token and change it around and say, well, if I were able to hack into it and say, well, this says I should have access for user ID number 502, but I'm just going to change it to 603 so I can get that person's info, the server will know. So in that way, I have access to my stuff, The only way I can get a valid token is from the server, so I have access to anything relevant to me and my account. But if I, the client, go in and try to tamper with it, which wouldn't be too hard to just tamper with it, what will happen is when I send it back to the server, they're going to know and they're going to deny me access. So that's the theory behind it. And we'll be, as we go through tonight, I think this will start to make more and more sense. Does anyone have any questions or comments about that just from the get-go before I share my screen and we start to look at some examples of what these tokens really look like? Any questions about what I've explained so far? Or any confusion about what the difference between a session and a web token is? Is the server decrypting the token with every request? Yes, absolutely. So the token will need to be, just like the cookie, it will need to come along for the ride on every single request, and it will be decrypted. But if we kind of do a compare and contrast, now the server, instead of having to access a database or a data store, it just has to access this one secret key and decrypt. And a decrypting operation is far easier than trying to access something in an external store. Where is the token stored in the client? We will spend all of Wednesday talking about the client side of this token business, but the short answer is local storage is perfectly fine. Sometimes it's even stored inside of a cookie, inside of local storage. All right, final questions? Not seeing anything. Oh, someone's typing. And you might have even tapped into one of the security risks, and one of the what not to do is takeaways from tonight and Wednesday's lecture, which is that if your friend's laptop is sitting open on their computer, you could probably go into their local storage and find a token. And as long as you don't tamper with it, it's still going to be valid, even if you take it and use it on your machine. So that's not ideal. Don't do that to people, but you can. Is a token wrapped in a cookie? We will not be, often it is, for our purposes, we'll just be leaving the token as a token. So you will see that tokens and cookies can and often are used together. But for our purposes this week, we'll just be using tokens on their own. All right, let me go ahead and share my screen so that we can take a look at how these things work. All right, so the page I have open here is JWT JSON-WebToken.io, which the fact that it's JSON Web Token will probably give you a little clue that underneath this, we just have a couple of JSON objects. So we have JSON-WebToken.io. It's easy URL to get to, but I'll post it in Slack anyways. I highly recommend you guys check this out. Especially if you want more information. There's a lot of great information within this site. So, but we'll play around this. Learn more about JSON Web Tokens would be the first place I would go if you want to dive deeper into the material from tonight. So let's go ahead and take a look at what this thing literally is. So I've described these web tokens as these access passes, which is an excellent way to conceptualize it, but literally what is it? Well, the thing that's actually being sent back and forth is a giant, ugly string. In the security world, we love these giant, ugly strings, you will come to find. Specifically, though, it's split into 3 different parts. And even in the encoded version, you can see that, because you can see that there's these 3 strings of letters and numbers separated by dots. So web tokens will always come in this format. And each one of these 3 parts represents a different JSON object that's been encrypted. So the client only has access to this ugly thing. Theoretically, they might be able to somehow find the key within the server and decrypt it. So you don't want to put like a password hash or anything like that in here. But ideally, they do not hack into your server and find your keys. So all they have is this encoded thing. All right, let's talk about the 3 parts of a web token. The very first one is the header. The header is metadata. It, for example, might include which algorithm was used to code and decode this. So the header, we need to know it's there, but we don't really care too much about it. The library we're going to be working with tonight will take care of all that business. What we're most interested in is the middle section, what's called the payload. So we would think of the payload as the part that we're most working with, that we, the backend developer, want to work with and put information inside of. So this is really what we're mostly interested in when we're creating our web token and when we're decoding it to confirm. So this is going to contain any information about the user that we need. Often what you'd see in here is some sort of user ID, perhaps a username, any data like roles or privileges. So this is what we will be reading from when we see if they have access or not, right? So when we're doing the actual authorization side, right? So authentication will be handled by using bcrypt to compare passwords, and then we'll generate this on authentication. That's when they log in. Authorization is when they try to hit a protected endpoint, and that's when we will decode our token. We'll see what's in here, and for example, we'll check to see, does the endpoint have to do with the user ID that's stored in here? So that's the payload, and really the most important part of this in terms of the practical request by request use. So the last part is the verify signature, and this is where the magic happens. And this is, as I said when we were just talking about the theory before I shared my screen, the key to this working is that we want to make sure it has not been tampered with. Because theoretically, if I just was able to if I was able to decrypt this thing using an algorithm, I could change the ID here. I could change the payload data so that I was all of a sudden magically authorized to see your bank account info instead of mine. We don't want that. So this verify signature will actually be generated based on the entirety of the data here. So we don't have to get into the details of how this works, but the short answer is that if anything changes, if any bit of information in the payload or the header changes, this thing will set off the alarm bells when we decode it. So once again, we don't have to worry too much about the weeds here because our library will take care of this for us. What we need to understand, the most important takeaway of the verify signature, is that it will guarantee that this payload data or anything in here has not been tampered with. So that is really the key to why this works and why this is secure. Because otherwise it would be just way too easy to go in and change the payload data and auto-authorize yourself to see things you shouldn't see. So that is what a JSON web token looks like. As it's being sent back and forth, it's just this encoded string, technically 3 strings separated by dots, and each of those represents a different object containing metadata in the case of the header, the actual user data in the payload, and then the verify signature, which is how we confirm that nothing has been tampered with. So for example, I think we can, see if I just change one thing in the encode, it gets in trouble. So a nice little resource down here that might be good to know if you're ever trying to do web tokens in a different language is there's a giant list of all these libraries that we might use for this. We care about Node, so let's see what they've got. And this is the one that we're going to be using tonight, is JSON Web Token. Notice that it has a list of everything that we can use this library for, versions and stuff. We're mostly concerned all of this would come up if you got really into the weeds of this stuff. But we are just worried about signing and verifying. So what we're going to be implementing tonight with this library is the process of signing and verifying. And these are two terms I want you guys to know with respect to web tokens. So based on what I've told you so far about how these things work, what do you think signing is when it comes to web tokens? What do you think the signing process is? And what do you think the verify process refers to? Any guesses on what these two web token terms might mean? So signing is when the server first creates, so it generates and sends the web token. And verifying is pretty obvious. It's when it checks the token from the request. So you can think about these two terms as really having to do with this signature at the end, this mysterious third part of our token. So we call it signing because, remember, we are imprinting it with, it's basically like we're, the king or whoever has the seal, the wax seal that they put on their letter, so you know it's official. That's exactly the same concept here, though, a bit more sophisticated than a wax seal. We're signing it in a way so that we know if anyone has messed with it. And the verifying is essentially making sure our metaphorical wax seal has not been broken, making sure that no one has tampered with this token. So that's what we're going to do. All right. So let's go ahead and jump on into the guided project. I already have that pulled down on my computer, but I will, hopefully you guys too. I will post that in Slack for anyone who has not. So there is our guided project. And before we dive into that, any questions on, final questions on this web token stuff, now that we've seen a little bit more of a tangible representation of it? What is algorithm in the header? So this is the algorithm that we're using to actually encode this. I personally do not know too much about the different algorithms and reasons to use different ones. I trust the library to take care of that. Okay, let's jump on over into our guided project. So there's a lot of stuff going on already in this, which is great because we can jump right into the meat of it. But my recommendation, both within a guided project or a homework project, or especially out in the real world, is to take some time to get to know the code base you're working with before you jump in. So let's go ahead and do that. We see lots of familiar things here. Index.js is just where we're listening. Server.js is where we start out our server. We can see that Helmet and cores, as well as our body parser, are already all plugged in. And we can also see that there's two routers here. So we have an auth router and a users router. The users router is just going to be our basic, endpoints having to do with actually extracting users. So in users, we can see our users router. There's just a single get for getting a master list of users in here, but we can imagine there might be some posts and, well, probably not posts because that's actually sign up, but there might be more specific gets in here, or maybe even deletes, things like that. But right now, our user router just contains this one get endpoint. And that, of course, uses a users model, which is just database helpers for users. And then in our auth router, we have the fun stuff. So we see that there is a register endpoint and a login endpoint. And we already have bcrypt all set up for us. So this is, you've now seen bcrypt in action twice. same old. We're hashing our passwords and then using compare to verify on login. So this is all set up for us. Our only job here is to make sure that we're signing our web token and then verifying it. We see that there's some fun middleware in here that a restriction middleware that we will be playing with as well. And then we see that we have a user table that's pretty simple here, just a username and a password. So nothing you guys haven't seen before. Everything is nicely laid out for us to jump in and start to play with this web token stuff. So I'm going to go ahead and start by adding this library in here. So up here I have, I'll post this for you guys too in case you're curious. This is the NPM documentation for JSON web token. So let me go ahead and add this in here. I'll install first. Okay. So what file do you think we want to, here's a little, this is a nice exercise, I think, for getting oriented in new code bases. So where do you think our starting point should be? We've seen what we have so far. We kind of more or less know what we need to add. What file do you think should be our starting point where we should start to implement this JSON web token library? Any ideas? So, ooh, we have a lot of different suggestions. I like this. This will be a chance for us to go on a second tour. All right, let's see. So first suggestion was in server.js. So right now, server.js handles the root endpoint, which just sends back it's alive. And apart from that, it's just really plugging in the middleware on the routers. So I'm not really seeing anywhere to work on this here because mostly this file is serving as a gateway into all the other files that have the interesting logic in it. So the next suggestion we got was the restricted middleware. However, I will say that server.js is a great place to start because you never know. That is the gateway into everything else. So server.js is a great place to start. But having arrived here, we might see, this isn't quite what we want. So let's use this as our starting point though. There's a clue within, we're sleuthing around the code base. So there is a clue within this file that tells us where we might want to go. And my hint to you is which endpoints might people be hitting when we're actually using this, this web token stuff? I see someone's pointing, a couple people, or just one person has pointed at the auth router. So API auth, this is where login and register are going to live. And notice that this points us towards the auth router, which is in this auth router file. So let's check that out. And sure enough, we see the register and the login endpoints in here. And this is exactly where we want to be. So there's no need to create a new file. Another important rule of thumb when working with an unfamiliar code base is it's always tempting to create a new file, but check and see if the file you want exists first. I can't tell you how many times I've started coding something out and then realized that someone else had already done half the work I just did for me. So another reason it's worth getting acquainted to the code base. And there's a reason I'm spending time and energy on this because this is one of those things that it's easy to take for granted, but it's one of the hardest parts of programming, is just making sense of this existing logic. So I actually really like this guided project today for that reason. All right, so without getting into code too much, what do we want to see, just on a high level logic, what do we want to see inside of register? What should happen when someone registers? Assign, yeah. So really, the most important thing that happens when someone registers is that we hash the password and store the user. That is already in there for us. In a nicely working app, you would hope that register automatically logs you in as well. So theoretically, we would want to see a sign in here. So I'll put a note that says, in a real app, we would want to sign a token and register. Because it's going to be the same logic in register and login, we're going to actually skip this step and just move right along to login. So this is where the really fun stuff happens. They're now verifying themselves. And I don't mean token verify, I just mean in the larger auth sense. So they are authenticating themselves, and that logic is in here for us. We're checking with bcrypt to make sure they are who they say they are. And then right now, all login does is say, hey, welcome user. So that's cool, but not ideal. So let's go ahead and just play, before we even get into the web token stuff, let's play with these two endpoints a little bit and make sure they're working. Another good tip when jumping into someone else's code base is we hope it's working well, but it's worth tinkering around with to make sure that it's doing what it should be doing. So I'll start my server. Actually, let's and go into Postman. So the first thing I want to do is register. And I'll use my go-to username Deandra, password pass. Let's do 1, 2, 3. Try it out. Uh-oh. Something's gone wrong. Post, thank you. Let's try that again. All right, and it's just not totally ideal because it's sending back my password, or my hashed password, but we see that I have been created. I have been created, I am alive. And let's go ahead and register a couple other users just so we have some fun stuff in the database. So all right. And while we're at it, let's try and, I'll do this in the browser. Nah, we'll just stay in here. I'll go ahead and try and do a GET request to this API users. So this is supposed to be the master list of users. And that's good, because right now it's just completely locking me out. It's saying, nope, no credentials have been provided. But if we wanted to confirm that, these 3 users that I've just created are actually in our database, we could always jump in with I want to say SQLite Studio. Sorry, we changed which app we're using recently. We could always jump in with SQLite Studio and look in the database and confirm that those items are there. So we're pretty sure there are 3 users stored in our database right now. We just can't see them via the API because there's no web token logic in place yet. And then if I go ahead and try to, is it login or sign in? Let's see. If I go ahead and try to log in, what am I going to see? I'm going to put in my valid username and password. So if I do a post to log in with a correct username and password, based on the code that's here, what should I expect to see in Postman? This welcome message, exactly. And it's even going to pull my name out. Nice. So I feel welcome, but of course, I'm no closer to actually seeing this list of users. So now we get to implement the fun logic. All right, well, let's start off by requiring this library that we added. And we're mostly interested in, let me pull up the docs real quick. We're mostly interested in the sign function, and then in a minute, we'll work with the verify function as well. But for now, for sign in, we're really just interested in signing. So let's play with it. Okay. And in fact, I'm actually going to go ahead and create a helper function because this library can get a little verbose. So I'm going to go ahead and create a helper function down here called generate token. And this takes in a user object and it will resolve to a, actually, I don't think we're using any promises here, so it will just return out a token. All right, so the first thing we need to do is create our payload. Anyone want to remind me what the payload is? My hint is it's one of the 3 parts of the web token. Anyone remember which part the payload is? It's the middle. And I like this, it's the body of the token. So we don't necessarily use the term body, but I think you're absolutely on target. It's where the meat of the data goes. The meat in the sandwich, love it. Exactly. The payload is the meat in the sandwich. That should be the one takeaway of tonight, apart from don't steal your friends' tokens off their computers. It's rude. All right, so if I keep saying that, you guys are going to do it, so I'll stop. I'm like tempting you. So we're going to start off with something called the subject, which is just going to be our user ID. We also want the username. As mentioned, there might be other information in here. Some roles or privileges are quite common to see inside of here. What bit of data do we not want to include inside of the payload? What would probably be a bad idea to put inside of our payload here? The password, yep. Social security number, also something we don't. Sensitive medical data, all good things not to include in here. So this will be encrypted, but encryption is not the best. Remember, the real thing that makes these tokens secure is the signature. So hopefully no one's unencrypting these, but they might. So we really don't want to include anything too sensitive in here. All right. So the next thing we want to create is options. And this is just something that's specific to the library we're using. And if you want to poke around in the documentation, you can see other potential options, but the main one we care about is expires in. And we're going to say 1 day, so 1D. I do want to point out, in case you want to play around with this expiration thing, it's obviously, this is maybe not obvious that 1D would be how you say 1 day in this library. So notice that in this docs, there's some information about expires in and different formats that are accepted here. And there's also a not before, which is another version of saying when it should expire. So if you want to play around with this option here or see other options, feel free to check out the docs here. We'll just worry about expires in though. So that's really all we need, except there's one other important thing. One other very, very important thing we're going to need. And that's a secret passphrase. So the trick to the verify, and in fact, the one thing that the server is responsible for keeping track of when we're using tokens is some sort of web token secret. So we can, of course, say and then we could create our token. So sign takes in 2 required arguments. We have to put in the payload and the secret, and then we can put in options as well. The options being optional. Okay, this will work, but yeah, hard coding in our secret phrase, especially inside of our generate token helper function, is not so good. Not such a good thing. So where might really the most important thing here is that we want to make sure this is not pushed up to GitHub. So whenever we have a secret of some sort, it needs to go in some other file that is get ignored. The environment file is one option. We're actually going to put it, we have a config secrets file here. So one folder we have not explored yet is, where are you? I thought there was a config file. Oh, well, I guess there isn't a config file. We will create a config file then. Or a config folder. All right, so let's make a directory called config. And then inside of that, I want to create secrets.js. And I'm going to make sure that inside of my get ignore, actually, let's go ahead and put our entire config file in here. Trying to find a good place for it, we'll just say. Yeah, we'll do, there might be other config stuff actually. So we'll do, that should work. Cool. All right, so now we know that that will not be pushed up. So what we can do inside of here is we'll just do a module.exports, and we'll call this thing Java or JSON web token. I always want to say JavaScript. JSON web token secrets. And what we would probably see is an environment variable, but we're not going to set that. So we'll say all right. Little reminder about this process.env. This is an environment variable. So that's just saying that this can be set in real time. So it could be set independently on production. And then this is just our backup plan. So we'll use this backup for now, but know that we'd really want it coming from the environment. So, and in fact, if we were pulling it off of this, we wouldn't even really have to worry about get ignoring secrets because you wouldn't know anything if you just saw this piece, right? All you would know is that somewhere someone was going to set the secret code. You wouldn't know what it was. So long story short is there is going to be a secret phrase and we want to make sure that it is actually kept secret. And there's different ways to do that. One would be hard coding it into a file that's get ignored so that everyone on the team independently has to set it. But a better way would be to let it be an environment variable. All right, so back over here, we have created this generate token helper function. This thing takes in a user object. We use that user to create a payload containing the information we want to store on our token. We went ahead and set an expiration date on our options. And then we now no longer want to hard code in the secrets. Instead, we want to require, let's go ahead and require make sure. Okay, so we're just pulling off that one key we care about and storing it here so that we can now pass this in. All right. I'm going to give you guys a minute to catch up and get up to speed with this generate token helper function. Any questions about what we've done here so far? The last thing I wrote at the very top. So what I did is I required this file, and then because this line here in Node just resolves to an object, I went ahead and just pulled the key I wanted off of. I could have also stored this as secrets. This would be an equivalent way, as I could have said secrets equals and then down here instead I could have done secrets dot. So I'm just accessing the key in the require statement. So equivalent ways of doing the same thing. I'll put it back. The main reason to do it this way is if I know I don't really care about any of the other properties off of this, I can just pull off the one thing I care about. I could have also deconstructed it. So 3 ways to do the same thing. Hopefully that, I probably just confused you even more. There are 3 ways to do the same thing. Does it affect the efficiency of the app? Yes, destructuring is the prettiest. It would if this thing were some gigantic object, then it would be, for efficiency's sake, it would be better to just pull off the key or keys we need. It's not a major thing though. Every token has a different secret. No, so we're actually just using the same secret for every single token. So there's one secret that the user is keeping track of. Or sorry, the server is keeping track of one secret, and that's really the only thing it needs to keep track of. So we'd pretty much be back in the same position we were in with sessions if we had a different secret. Because we need some way of knowing which secret goes with which token. But because we just have almost a skeleton key that goes to every single token, all we are worrying about is has this token been tampered with, first of all, and then is this user authorized to see whatever they're trying to see right now? Could you use multiple secrets on one server? Theoretically, if it were separate portals of some sort. So if there were if there were different places you were being authenticated, for example, or if there were a user login versus an admin login, maybe you could use different secrets, but you'd really be in trouble if you ever had multiple secrets because you wouldn't know which one goes with a token. There'd be no way. The user clones that GitHub, do they know that secret or configure the secret file? So usually what happens with an environment file or a secret file of some sort is that if you're, let's say I join the team and I clone this down, and what I would see is this config would be empty. So one of the steps in my README would probably say, create secret.js and get these secrets from your teammates. And then I would create this file, and it would probably tell me how to format it, or maybe a stubbed out version would be included. You'll often see that there's a stubbed out version included, so that I can then copy it over, and then I'll get that information directly from the security team so I can plug it in on my local copy. All right. I think now is a good opportunity to take a break. So I'll go ahead and give you guys 5 minutes. And then when you come back, first of all, we'll use our generate token helper function to make our login request actually log you in. And then we'll play around with that restricted endpoint to get those users so that we can actually see our list of users. All right, so go ahead and take 5. All right, welcome back. So we've created this, created this awesome generate token helper function, and we know that we need to implement this somewhere in the login. So where within this login logic would we expect to see the actual generation of the token? Where within this whole callback function should we use generate token? What do you guys think? After line 30. Awesome. That's exactly right. So this is the moment that we have successfully authorized that we have successfully authenticated our user. I like this, authorized. It's very sci-fi. Authenticated. Fake programming terms with Deandra. Another way to think about it is right before we send the response. So that's a great way to find the appropriate spot to generate a token. It should be immediately before we send back that 200, because that is the moment that we know that, yes, everything else is good. We do not want to be sending back a token on any of these other response scenarios. So here is the appropriate moment. So it's pretty simple at this point. We'll go ahead and create a token using our helper function. We, of course, need to pass in the user. Remember, user referring to the user that we actually found from the database. You would not want to pass in info from rec.body in case there were maybe the username and password is correct, but there's something else weird on there. This should always come from what's in the database. So we're going to generate that token, and then we'll just go ahead and send that back. Actually, we can just do that. Okay. So we will send back the token as well as the message. Let's see the magic happen. So log in. It's worth, let's go ahead and let's make sure I don't get a token with the wrong password. Always worth checking. Okay, still getting invalid credentials. And then I put this back and send it. And there it is. And just like we expected, we see these 3 crazy looking encoded chunks of text separated by dots. So we know that we have our header, our payload, and this. And actually, let's, by the way, a word to the wise. This is, pay attention here. This is like, if you miss this, there might be some wanting to smash your keyboard moments. When you're copying your token, do not include the quotes. Otherwise, it will interpret those as being part of the token. So make sure you only copy what is in the quotes. So let me try this out. I don't think I've done this before, but I think it'll work. If we, so because we're using a familiar algorithm, oh, I see. Okay, because we're using this familiar algorithm, we're actually able to easily decode this. See, I can see my name and my user ID in here. However, because we do not know my secret, we can't change this around to be a valid token. So if I switch this to subject 2 and tried to send this back, we'd be in trouble. Let's even play with that later. So let's leave it alone for now, but we can actually see that this app just completely decodes my token easily because it's using a familiar algorithm. All right, so we have logged in, and we, the client, generally this token would be handled by the actual front end code, but we're gonna do it manually for tonight, and we'll see how it actually works on Wednesday. So now we have access to this token. All right, next step is we want to be able to use this token to actually see a protected endpoint. So let's go over back in here and jump on over to users, user router. So we have this get endpoint, and we already have restricted middleware in place. We saw that when we tried to do requests. There's some sort of restricted middleware that's preventing us from getting in here. So this is really where we want some more token logic, right? This restricted, my guess is right now, it's just hard-coded, not letting us in. But we want something a little more sophisticated to happen with our token. So let's go, I guess, back over to Auth and this restricted middleware. We'll play around with what's in here. All right, so how is this, actually, it's not hard-coded. How is this restricted middleware working currently? Without use of this web token, we could actually pretty quickly change something up in Postman to allow us to see this list of users. What could we do in Postman right now to make it so that we can see our list of users? It's looking for the username and password in the headers. This is definitely not how you want to be sending them, but let's do it. So we have username, Deandra, and password, pass123. And there we go. We can see all 3 of our users now. So that's cool and all, but what do we really want to happen here? We want to refactor this. I will actually even comment out the old version just so we have it for reference. But we want to refactor this. So how should it work when our work here is done? So I see a couple suggestions. Check the header for a token. One is test the login credentials and the web token. So here's the key point, is that we should not need the login credentials, right? This validation should be hit after someone theoretically has already logged in. They've already authorized themselves. Or sorry, they've already authenticated themselves. Now we're seeing if they're authorized to access this endpoint. So we don't care about the login credentials anymore. At this point, what we'd really want to do, I'm going to wipe the slate clean here, is we'd want to check for a valid web token is step 1. And then step 2 would be make sure the user is authorized to see this endpoint. So we're not really going to be worrying about step 2 because the way we're setting this up is that as long as you have a valid web token, everyone's welcome to see this endpoint. And there are endpoints that are like this. As long as you're just past the portal, you can see it. But in a more sophisticated restriction middleware, we might go a step further. For example, if you're just seeing the welcome page, once you're logged in, all you'd care is that they had a valid web token. But if they were trying to get their private messages, then you'd want to make sure that they had a user ID that matched the user ID that they were querying for. So really, that's the only thing we need to do here, is we need to check that a token exists and verify that it has not been tampered with. And once we've done that, they should be free to go. So we're going to pull this token off of the headers. And a standard header that you would expect to see a token on is a header called authorization. So it doesn't have to be this, but this is kind of our default. So that's where you want to put your token, both as a front-end user, you want to put it there, and as a back-end developer, you want to look there for a token. But first, we're going to see if the token even exists. And if not, we can send back something to the effect of inside here, we're gonna, well, first of all, we need to require a couple things. Let's start with our web token library. I'm also, while I'm up here, just going to go ahead and grab this secrets file. We will need our secret key to verify. Actually, let's do that same thing here. Okay, cool. All right, so who can explain to me what needs to happen within here? And it's pretty straightforward because we'll actually be using a built-in verify function. But at a high level, who can explain to me what will happen if the token exists? We do need to verify it, but maybe let me ask a little more specifically. How does the secret phrase play into this? Why is it important that we have the secret phrase when we're trying to verify? It actually won't decrypt the info because, remember, I was able to decrypt it just by knowing the algorithm. So the decrypting part is pretty simple. Really, anyone could do it. But we want to make sure the token has not changed. Exactly. That's the key, is that what we're most interested in here is making sure that no one has tampered with our token. And the only way to do that is with our secret phrase. So we're going to use this verify function that's built into the library. It expects a token and then a secret, and then a callback function that gives us an error and a decoded token. So we can handle the error down here. And the error, this is what will be triggered if it has in fact been tampered with. So we could say something like, we'll just send back the same message here. This is another case where we actually don't want to get more specific because we don't want to give our potential hackers any more information than necessary about what went wrong. Okay. So if there's no error, we can assume that all is fine and good with our token. So we can now say next. And they're free to move on to whatever they're trying to get. Another nice thing we might add in here is we might actually attach the token onto our rect object. So this will just make sure that if we ever need access to the token for anything else down the pipeline, we have it available to us. And I'll even go ahead and console log that so we can see it back here. Okay. Cool. So let's see it in action. Oops. Postman. All right. So what do I need to change in the headers, right? This should not work anymore. If I send, I now have the username and password here, but doesn't work because we're not interested in seeing credentials at this point. We just want to see the token. So what do I need to change in Postman so that I'll be able to access this endpoint given the refactor we just did? Authorization, yep. And then we'll pull the token. Remember, no quotes. If we put the quotes in, we'll be in trouble. Let's try it out. And ta-da. All right, the last thing I want to do here is, what if I decided, ooh, I want to pretend to be Stevie? That would be fun. So I could go in here and change the payload. And I could use this or another page to get a token, right? So this is the token that contains that payload and those headers, but it doesn't work, right? Because this signature will only work with the original payload data. Basically, to give you maybe a little bit more insight of what's happening here, is it's actually, this encrypted bit actually includes information from the payload plus the secret. So the magic sauce you need to make this is you need to know the original payload and the secret. So if one has changed, the payload, you're going to be in trouble. So you would really need to know both the new payload data and the secret to create a fake verify signature, which you could do if you had the secret, but hopefully you don't. All right, let me give you guys a chance to catch up with all this and ask any questions you have about what we've just done here. Can we see oh yes, the console log. Thank you for reminding me. Yep, so we see that the token is confirmed and we can see our payload data down here. Is it common to see a token as an HTTP header? Yes. And specifically to see it as the authorization header. In fact, I don't know if you guys noticed, but when I started typing, it actually auto-suggested that for me because it's an expected. Yep, so it's secure. I mean, first of all, it's encoded, so it is secure. Excuse me. But even if you do decrypt it, it shouldn't contain anything that really would be critical for someone to see that they're not supposed to. Yep, and so the client's job is to set this. And this is, so what we'll be working on Wednesday is essentially the second half of this lecture, which is we'll be playing with React and seeing how we would set this up on the client side and how we would handle it from the client's perspective. Great. So the last thing I want to talk to you guys about is a little bit of how this works in the real world. So as has been the case, especially in this auth section, we really like to do this stuff ourselves and to understand a little bit of what goes into it. But as I mentioned on night one of this sprint, mostly we don't want to do this as developers. We want to leave this to the experts. And so a little bit of a sense of maybe what goes on with web tokens out there and some terminology you might be interested in. So first of all, web tokens are the most common way that, that this type of thing is handled. So we really like web tokens, especially compared to sessions, because of the scalability issue that we've discussed. And in fact, and so the most common way that a web app would actually implement this would be using OAuth, particularly OAuth 2, which is a library that allows you to use other people's authentication systems like Facebook's or GitHub's. And then there's a library called ID Connect. So OAuth 2 and ID Connect. I'll put those up on screen if you guys want to check them out. Oops. OAuth 2 with ID Connect. So these are the two most common libraries for implementing this while outsourcing the real logic elsewhere. Another thing I just wanted to mention, because it's interesting to know, is that often there are actually two different or even more types of tokens that are used. So there's an ID versus an access token, often that are handled completely separately. And we've talked a lot about this difference between authentication versus authorization, except when I'm accidentally combining those words into one nonsense word. So an ID token is kind of like an authentication token. It says who you are. And then an access token is more like authorization. So an ID token would say who you are, and an access token would say what you're allowed to see. And so a lot of the times, if you're looking, for example, at the documentation for these libraries, you might see those terms and be wondering the difference. So I thought I'd throw that out there. So beyond that, using these libraries really just comes down to playing with the docs, tinkering with them, finding resources. So I know a lot of folks are usually interested in playing with them when it comes to projects and labs. So I just wanted to put out a few little fun tidbits about them while we were at it. All right. Well, tonight is a little bit of a shorter night, so we're pretty much done. I'm going to go ahead and talk to you guys about the project for tonight, and then I will open up the floor if anyone has any final questions about this. All right, so this is our challenge for tonight. And what you'll find with this challenge is that most of it is going to be review. You're really starting from scratch. It's kind of the opposite of the guided project. Notice we only have 2 files in here, a get ignore and a readme. So you guys will have to be doing everything that we've been practicing from night 1 on here. You'll have to set up a database. You'll have to build out some endpoints. If you want to separate things into routers, you're welcome to. If you want to play with file structures, I would recommend taking a look at this guided project because it has everything separated out in a really nice modular way. So lots of review in terms of building out all that fun server express endpoint stuff and then setting up your database. And then finally, you'll get a chance to play with bcrypt again because you want to make sure that your passwords are being hashed and verified using bcrypt. All the specifications for that are in here, but you'll find that maybe our specifications are getting a little bit vaguer, a little bit more vague as we go along because we want you guys to be making decisions. In the real world, usually someone's not telling you exactly how to build it. You have to make decisions. So we're letting you do that too. And then finally, we specify which of the 3 endpoints that we really want you to work with. Really similar to what we saw tonight, a register, a login, and then a get master list of users. So that is, so that's what you guys are up to. So really the only thing you'll be applying that we learned tonight is what we just worked through. You'll be working with generating a token on login and then using that token on get so that hopefully with middleware, I don't think it specifically says middleware, but middleware might be a good idea, so that this endpoint is restricted and you only see it if you've successfully logged in. There is a part 2 here. If you're feeling adventurous, you could start to play with the React side, but we'll go over all of this on Wednesday, and this will be your challenge for after the lecture Wednesday. Notice that there is a stretch. The first stretch problem applies to what we've learned tonight. So this is kind of cool. I would, especially because a lot of this is review, I would definitely recommend playing with the stretch problem. So the idea here is that instead of getting a master list, you only get a list of users whose department matches. So notice that our user schema has a username, a password, and a department. So let me just play with this for a second here, just so we can think about how we would handle this. So in restricted middleware, notice that we attach the decoded web token onto our rec. So what we could then do potentially is go into our users router and have something like, we could pull off department, if that, or maybe role, just to use a slightly different example. So rec dot decoded token, if that's what it's called, dot role, we could potentially pull a role off, and then maybe instead of find, there's find by role, and we do something like that. The gist here being that now our endpoint is actually reacting to the web token in a more dynamic way. And this is the kind of thing you would see, is that not only is the token used to authorize someone, but then we use some of the information from the token to actually determine what data they're seeing. So in this case, the logic does not exist. There is no find by role here. But we can imagine that there is some database helper that now only finds certain users based on a role. So that depending on whose token you have, you would see a different list of users. So I like this stretch problem a lot because I think it really taps into one of the core ways that tokens are truly used, which is to dynamically change what you're seeing based on who you are. So a little suggestion of something you might do. All right, that's the homework. I'll send you guys the link so you don't have to go digging for it. And you guys were done almost half an hour early, actually over half an hour early, so you will have a head start on this. Before we call it a night though, any final questions about any of this stuff? The thing I said that could lead to great frustration. Yes, awesome suggestion. I will show you, in fact. Okay, so here we go. We go ahead and log in. So I log in and I get my token, and you guys will have to do this to manually test it. And I copy my token and I put it in here, but it's not working. What has gone wrong? What have I done wrong? The quotes, yes. So it is interpreting the quotes as being part of the token. So make sure that when you copy this from whatever is sent back, that you exclude the quotes. Other questions? All right, that's my cue to let you guys get to the homework. Well, I hope you guys learned a lot about web tokens and how they work, how they differ from sessions. I will see you on Wednesday, and we will context switch over to React and play with how the front end will handle tokens. Good luck with the assignments, and I'll see you guys then.